how great guys they are. And today they are going to talk about how they took care of native apps using QT and GStreamer, so something that falls exactly within the context of presentations that we've doing so far. So looking forward to their talk. Thanks.
Okay, thank you. You can hear me, yeah? Good morning, everybody. So it's almost the last talk, so it's very late, but I try to make it as painless as possible for you. So I'm talking today together with my colleague Jan here from Pascom about native apps using QT and GStreamer. And first, a bit about the details of this talk. So I will not talk about fruits again because we heard everything, I think. This talk will not include any code snippets and really low-level detail because two other guys today handled that very well. So on the one hand, Anand told us a lot about GStreamer, so you should know everything which is important. And Dr. Alex made very good ground for our talk referring about the QT. So I can remove this low-level detail from us. Okay, a bit about my company or our company. We're doing PBX solutions actually since more than 10 years now. We have a lot of Asterisk and Kamailio in our product. And since 1 year, we're integrating now Janus and video based on WebRTC. This talk, again, is about our client product, not about the server. So the client is running on the 5 major platforms, so Android, iOS, Windows, Apple, and not to forget Linux. And first, the question is why do we need a desktop app at all? Everything is running in the browser today, so why are we doing this? So most applications are moving away from the desktop and are going to the browser. Think about a mail client or something like that. Nobody would actually build a native mail client anymore, I think. But yeah, we're doing this for our web client. So this is the situation a bit on the desktop. So most of the stuff is moving to the browser, but there is still some place where a desktop app can still be valuable today, and if it's very well integrated to the environment. So there are a few things which are relatively hard to achieve in the browser, but much simpler in a native app or in a desktop app.
So yeah, basically, just to reiterate, it's again not about using web technology to build a native app like Dan does. It's really having some in-browser only solution, which is more like a progressive web app, versus doing really an installable desktop application. So why to do this? Yeah, the basic is you can much better integrate and much more tightly integrate to the underlying operating system, being it the much mentioned call kit, which you can see on the right screen, which also basically just works. As you can see, it's Pascom audio. So it's our own application and not some real GSM call or whatever, or even other stuff like tray icons and tray menus, which are common on Windows or also on macOS, despite being called differently, and also native notifications for chat messages or even calls or something like that's also on Windows. And the reasoning for this is, even if you build a beautiful UI, most people actually don't want really to, or some users of your application don't want to have it in the foreground all day. So probably they are not call center agents who phone all the day, but they are then doing a different work and just need to be reachable. They probably don't want to see that application at all until it needs some kind of interaction, like answer an incoming phone call. And it's going on from there. So it's also about collaborating with other apps. So for example, they want to be able to place their call from their Outlook address book or search their Outlook address book from within your app, or the same also for Android and iOS phone books. People just expect this. And also there are lots of legacy APIs you need to integrate because there are just a lot of existing ERP systems, for example, still using the TAPI interface from Microsoft, if someone knows that still. Who does know what TAPI means? Okay. It's some telephony interface back from the 1990s where still connected your plain old phone via some COM port and were able to remote control it. And basically many ERP systems using this today to place calls, but there is no COM port anymore, and otherwise you're making some SIP invites or something like that. Yeah, and you still have to deal with such legacy APIs, and I'm pretty sure that there is no React Native component for TAPI. Try to write one and tell me how it feels. Okay, yeah. And also, while I was talking about these plain old phones, you want to remote control them. Even if you're not using TAPI directly, but what the customer is expecting is that he selects his selects his contact he wants to phone in Outlook or somewhere else, and just click on the button, and the phone starts to phone. And he doesn't want to touch his nice shiny Snom or yelling phone or whatever. And this also can get very complicated depending on the network setup and everything else which the customer has. So you probably you just have an easier way to determine your environment if you're using a native app, because all the APIs are readily available to be integrated in or to integrate in your application. And also, at the same time, we are in 2019, the other half of your customers wants to have a soft phone because they don't want to have the hardware on the desk anymore. So actually, it should be the same, just the same experience like you were using a hardware or a soft phone. There shouldn't be any difference today anymore in 2019, except that for the one piece you need a piece of hardware, and for the other you need probably a different piece of hardware. And also you don't want to search for your browser tab first before you can accept some call, bringing me back to notifications and stuff like this. So, but also you need some kind of, if you are having a soft phone, you also need some way to transmit the audio to your ear. So, talking about headsets.
So yeah, we're using the Opus codec, and it has very good quality. But of course, if you have a crappy headset, it's not optimal. So you want a nice headset to leverage the Opus codec, and so we try to integrate some headsets. Somebody, if you ever integrated a headset SDK, somebody, one, okay, 2 people in the room, okay. So we did go down this road because customers wanted it. They say we're buying a headset, it has a couple of buttons, why can't I use them? So to show you what it means, here's an example of a very simple headset. So it looks familiar, it has a USB plug, you plug it in, it has a microphone, it has, in this case, stereo speakers, and it has a couple of buttons. Of course, it has hot plugs, so in your application you want to know, is it plugged in or out? What happens if you plug it in or out? You need to reroute the audio somehow, and you need to know if it's available or not. There's a volume control. Yeah, that's not so important for our talk here because it just works in hardware here. We don't have to take care about it. But then there is a button here. The customer expects to press it to accept the call. Yeah, it's just one button. Cannot be that hard, right? But actually there is a LED on it, and now you need to signalize the call state into the headset. It can blink, it can have the one color or the another color. And then if you're in the call, this single button gets a different meaning. You can press long on it to hold or unhold the call. You can have a short press to hang up the call. And this is not our idea. This is the vendor's idea what these buttons should do and what the LED should do. And that means you need to use the SDK, and you need to fully synchronize your softphone state into the headset so that it plays well with your application. So it's not so simple at the end, even if it has just one button. For the customer, again, it's very convenient because it's almost like using his plain old hardware IP phone. The application can be invisible in the background. I have a notification on the screen which tells me with whom I'm phoning, and everything else I do with this dedicated button, because the important interaction is accepting the call, terminating the call, and I don't have to search for a browser tab or something like that. So a complex example looks like this. It is a wireless headset, and it has even more features. It has a display, so you can signalize the call ID, the duration, and such things. It has a touch control, so you can actually control the call from here. It has, again, on the earpiece call control, so you can accept or terminate the call directly with a finger press on your ear. And it has a busy indicator, so if you have a room full of agents, you see who is phoning and who not. So integrating this seems to be very simple, but it isn't. It's a lot of low-level code that you need to write, and for each vendor, it's different code that you need to write, because everybody has different SDK. There is not really a standard. At least I'm not aware of any standard here. Okay, so that's about headsets.
Okay. But despite all this integration and going invisible and being to control via hardware or something like that, it's 2019 and the people just expect an awesome UI. It's just that they are used to really fluent interaction on iOS or something like that, and also that someone really had to think about this. So that's something you really can do also with web technology. But so it's not really an advantage of a native app or something like that. Probably some parts of web technology are even better suited like this. You can dispute along with this, but the digest of all of this, you need to think about your use cases, which where your app will be used, who will be using it, and why. So you can have different kinds of people, like for example a receptionist who probably has your application even on one dedicated screen, looking all the day, just distributing calls to different people in your company. Or you can have a call center agent who probably will use the hardware a lot, but still want to be able to, for example, to transferring, to be quickly bring it into the front and select another agent or some other specialist to transfer his support case to. Or you can have, yeah, some kind of stalker mode where, for example, someone just needs some kind of busy lamp field just to see who is available in the company and who is not. And therefore, yeah, you need a responsive UI, and it needs to present useful information at every screen size. So from a 24-inch desktop monitor to some 4-inch iPhone and everything, it just needs to work. And also, even with the most recent release of Apple, it should become clear you need to have a dark under the light theme today. It just needs to be there. It's nothing to argue about. So you need theming support and stuff like this, and it also needs to be designed carefully. So in our case, we just support it. Okay, then on to some implementation details on how we achieved all this technology.
Yeah. So what does it take to build an application like this? It's a lot of effort, of course. So what did we use to build it? First of all, especially about the video support, we decided for Janus. I'm not going into detail here because everybody in the room knows why we're using Janus, of course. Key for us was performance and the memory footprint, because it's considerably smaller than other solutions that we had in the past. It has a very nice modular architecture and a generic protocol. The protocol is important for us because we can simply hide it, because our own protocol, like probably a lot of other people are doing as well. And for now, all what we use from Janus is the beautiful video room plugin. It does exactly what we want. We didn't have any problem with it, and that's why I wanted to say a big thank you to Lorenzo and all of the team. Then what about the audio? We don't route audio into Janus yet. Maybe we do later, but at the moment audio is routed completely independent of the video support, because we're doing audio for a very long time. Video we're doing now for about a year, And audio is, by history, always terminated in the asterisk in a conf bridge if you have a conference call. Mainly also to the need that we have PSTN callers and legacy phones in the system. And then at the end in the server, we just try to build up a data model for our clients so that it doesn't matter if the video is routed one way, audio is routed the other way. In the future, we want to look into the Janus zip plugin to also use WebRTC audio and route it back into the asterisk. And by following the other talks today, I'm confident that this will work very well. Okay. So why QT? Thanks to Dr. Alex, we know why QT is really a great thing. For us, again, key was performance. So it's really fast because at the end it's native code. Even on Android, you can argue if C++ is native or Java is native, but from the perspective of the CPU, I think it's more native. It's very major. It has great documentation, and it never let us down. So it's around for a very long time. So it's really 23 years old. That's really a long time for an ecosystem. And even Android iOS support, it was added later, but it's around since 2013. Good thing is because it's that long around, the library is very complete. So you get all the tools that you will basically ever need. All the batteries are included. It has an IDE included if you don't want to set up something else. And also for the designer, it's very nice with this QML language which was added. It looks a little bit like JavaScript, but it can do actually a bit more. So that's about QT.
So somehow you need to get video frames into QT. And as we had in an earlier talk, native using the WebRTC or libWebRTC directly is probably a bit complex. And yeah, I also want to say thanks to Anand for his detailed GStreamer introduction, which was the alternative path we choose because it was just easier to integrate. For most platforms, the library is already available pre-built, and you just need to set up and link against it, which is already enough work in itself, but it's still easier than building libWebRTC itself. It's also around for a very long time, which is in our opinion usually a good thing if it's still actively maintained, because that usually means some kind of maturity and stability. And also on certain platforms it has hardware acceleration, or there are plugins available doing hardware acceleration. It has a very good documentation. Once you read the getting started guides, and then you can also go into details about every plugin, and then it's just usually useful information. And also it has, with the WebRTC bin, it has a very simply to use API. And there's also filters and codecs and stuff around for everything you need. For example, supporting some Android cameras having by default the wrong orientation, like landscape or something like this. And if you are not able to get the orientation information or to get the hardware to turn the image for you, there is a GStreamer plugin available just to turn it, the image. With libWebRTC, you need to write that code yourself or plumb something else in, at least as far as I know, and therefore it's just got you covered there. Okay, but there was one big problem. There is one integration readily available. It's called QML sync, and it does what it says. So a sync in GStreamer is some kind of output, either on the screen or to a file or something like that. It's something where media syncs into. And you need this just to display something. And the QML sync tries to share the OpenGL context, which, so just to do a short sidestep, QML is hardware accelerated by default. So they're building on top of OpenGL. And therefore there is some OpenGL context available. And that QML sync tries to hook into that context and uses it together. That has certain drawbacks. For example, on Windows, the OpenGL support is basically terrible because it depends entirely on the GPU driver of the vendor. For example, Intel or NVIDIA or something like that. And especially Intel is not actually known for good OpenGL support. And therefore there are bugs, for example, like we had, it's the lower link. There is some issue that you cannot have two simultaneous video streams within one Qt quick window using OpenGL or using this QML-GL sync. So what we did is build our own workaround, and we just have a very simple sync which just takes one frame and has one frame callback and exposes that to the Qt main loop, and then we then you can display it, and then you can display it using QAbstract video surface, which is one of the supported ways from Qt to display any kind of media within some QML UI. And the big advantage of this is that it works basically everywhere. It works on an old Android phone with an old or slow GPU. It works on an iPhone. It works on Windows when you're using one of the support libraries, for example, Angle, which is maintained by Google and used by Chrome to translate OpenGL raw calls into direct 3D to just work around buggy Intel drivers. And they're really buggy. So we have, the older the hardware gets, the worse the support is. So for example, we have customers with machines from 2008 or 9 which just basically have no working support. So that's it. We built our own sync plugin, and we plan to open source it in the near future and probably contribute it directly back to GStreamer. So on to the result. How does it look like? So we have here the main screen of our application with one chat view open, and you can see the video is embeddable directly into the screen, and even multiple screens are just possible without any hassle, and also overlaying or using effects on the video from QML is just works. So also you can have full screen video and overlays and chat overlays, and also something like MCUs does, some grid-like structure with multiple streams. And what's also a big advantage of a real native app is we can do screen sharing easily. So sharing your own screen is just a click of a button away. And even overlaying with a secondary video stream and stuff like this. For desktop, yes. On iOS, it's just a decision by Apple to just not allow it. So you cannot just record the screen there when your app is not active. So where we can support screen sharing, we will support it, of course. Yeah, but as other people already talked about, getting this to work on 5 different platforms is a huge amount of effort. So we go on and tell you a bit about this.
Yeah, so implementing this is the one story, but shipping it to the customer is the other story, and keeping it up to date is yet another story, and keeping it stable and so on. So the first challenge is you need to build it somehow. You need obviously a farm of build servers. If you have multiple platforms, you need multiple build servers. If you support multiple OS versions, you probably need even more build servers or containers or whatever is suitable for you. In our case, it's a Jenkins farm in vSphere, including some Mac OS machines which are causing a lot of trouble. But there is no chance. We need to do it. Yeah. Then every SDK or OS update, you need to go through it, and it will break usually your whole CI infrastructure on each major update, always.
Thank you, Apple.
Thank you, Apple. Yeah. So basically, you need one extra person just herding and maintaining these build servers. Yeah. So that's really causing a lot of work. Then the next challenge is testing. of course, we can have unit tests, but for the real test, you need humans. So you need an end-to-end interop testing. You need a lot of hardware. People doing this, you need some checklist tool so that you can actually repeat the test. Otherwise, your testers will just do the one thing on the one day and the other thing on the other day. So yeah, costs time, but it's very important. So unit tests are not enough. You need to have the device in your hand and you need to try it out in certain combinations. Okay, some things are really ugly to test. So we're supporting fax devices, as you see here. So you need some special equipment like this one with highly optimized test documents. You can see it on the picture. So it's really hard. By the way, we're hiring. So if you want to get nice equipment, just approach us. Okay, mobile devices are special, especially on Android, because fragmentation. Yeah, you need to test a whole range of Android operating system. Then you have a lot of screen sizes, even on iOS, that can be hard. So we're scaling down to this. What's the size? 4-inch screen on the iOS. And so you need to be careful when you design your UI. And then if you survive all this, you need to ship it somehow to the customer. Yeah. For the mobile devices, of course, you have to use, you cannot sidestep it. You have to use the app stores of the vendors. So that's Google Play or Apple's store. But then you want also to have something like public beta releases. Both of those vendors support this, but again, you have at least 2 channels how you distribute an app. You want to ship it to the beta testers or to the productive channel. And on the desktop, yeah, there is no clean standard. Of course, we could use the Windows App Store or something like this, or the Mac App Store for the Mac desktop app. But here we decided to not do it because at the moment we are not enforced to do it. So we did build up our own deployment infrastructure for the desktop applications with actually also multiple channels where we can do beta tests and stuff like that. Yeah, but even that is not all of shipping. If you shipped it, you want to get back telemetry from your clients, of course. You want to integrate some support tools. You want to have a way where the customer can upload log files. You want to have an automatic crash reporting with stack traces and. That's a lot of things that maybe the mobile device developer gets more or less for free, or the web application developer maybe has an advantage. But anyhow, we decided to go native on all the platforms, and so we need to do this. And that's actually all. So, do you have some questions?
Hey,
Hi.
great talk, really interesting.
Thank you.
So there's a lot of testing that goes on. How do you
Yes.
determine what device and what version of the software that runs on that device to test? Otherwise, you're going to be there forever. So how do you shrink that list?
Yeah, of course we had to shrink that list because, for example, Microsoft decides every half and a year to call their long-term servicing branches something different, and so you end up with a matrix with 20 entries. And usually for the desktop, we just supporting the latest and testing. On Windows, we're testing the latest patch sets. And but also, again, we have a lot of older customers, so it's the latest patched version of Windows 10 and Windows 7. And on macOS, we are also mostly adhering to what Apple supports. So it's, I think, 10.12, 10.13, 10.14, and upcoming 10.15. But it varies a lot, and it's also some kind of sliding window. And on iOS, we're doing the majority of testing according to the distribution chart, which usually is the newest version because iOS guys just update very fast. And on Android, yeah, it's Android.
Yeah, I was wondering what you was going to say on Android, but yeah, fair enough.
Yeah, we're trying to support actually, I think the lowest version is Android 6, AP level 23, and we're just using whatever devices we get a hold of and testing on various, but we cannot guarantee support on, or we cannot test on every platform, so we just do our best effort there and rely a lot also on customer bug reports.
Yeah. Okay, cool. Thanks.
Okay, maybe additionally, of course, we monitor which devices are actually used in the field, and depending on this feedback, we can do a few decisions. So, yeah.
Oh, thanks. Let's give the Thomas and Jan a big round of applause. Thank you. Thank you very much.